Hey everyone. Remember we just learned how to find the inverse of a matrix A by row reducing it alongside the identity matrix. So let's do that to find the inverse of this matrix or determine that the inverse doesn't exist. So remember that we're going to set up a sort of double augmented matrix that looks like that, which in our case is this. A lot of writing for sure. And then we do that. Okay. And I'm going to break my own rule and row reduce a couple of times in the same step if it's clear, right? So for example, I think here we're going to do negative 4r1 plus r2 to make this entry 0, and then 2r1 plus r3 to make that entry 0. Now remember, when we do these operations, make sure to apply them to the identity matrix as well, right? We're now doing two operations at the same time, right? So we do that. I think that becomes a 1. That becomes a negative 1. This becomes, right? And then this line becomes negative 4, 1, 0. This row becomes, what is that going to be? 0. 2r1 plus r3 becomes 2. 2r1 plus r3 becomes a 6. Meanwhile, this becomes 2, 0, 1. Okay. Now, what would be a good idea? I think we should do 2 times row 2 plus r1. And maybe if we can squeeze it in, I think we're okay with this. Negative 2r2 plus r3. Right? So applying negative 2 times r2 to r1, right, we're going to get 1, 0. And then I think that's going to be a negative 1. Then we apply that to here too, right? So 2r2 I think becomes a negative 7. No. Yeah. Negative 7. 2, 0. Okay, r2 always stays the same. And now we're also going to do negative 2 plus r3, right? So then that means this is going to be a 0. I think that's going to become an 8. I think we're getting a 10 right here. Negative 2. I think that's still a 1. And now at this point, let's just do 1/8 r3. Right? Try to avoid fractions when we can, but sometimes they're just unavoidable. Right? So all these will stay the same. When in particular, when you're finding the inverse of a matrix, you can't avoid fractions a lot of the time, as we're going to see in, for example, example 5. Actually, sorry, that should be a 5/4, right? And then this is a 1/8, right? And so then to polish it off, we're just going to do, again, breaking my own rule here, r3 plus r1, r3 plus r2. And this is going to give us the identity matrix here, right? Which is what we wanted. But what's it going to give us over here? Well, let's see. We've got r3. That's not going to change. But what about r1 and r2? Well, r1, negative 7 is negative 28 fourths plus 5 fourths. I think it's going to give us negative 23 fourths. Negative 1/4 plus 2, I think that's 7 fourths. And then 1/8 plus 0 is 1/8. Okay? And then what about the middle? Negative 4 becomes negative 16 fourths, and then plus 5 fourths becomes negative 11 fourths. I think 1 becomes 3 fourths, and then this again becomes 1/8. So A inverse equals this lovely matrix of negative 23 fourths, negative 11 fourths, going down 5 fourths, 7 fourths, 3 fourths. Just be clear, that's a negative. All right, negative 1/4, and then I guess 1/8 across last column. Now, of course, how can you verify this? Well, you can multiply it by A, and you should get the identity. That might look a little gross. So maybe what you could do is multiply A inverse by 8 to get rid of all the fractions. then multiply that by A, and then divide the whole thing by 8, and you should get the identity matrix. Okay. Next up, let's show that the inverse of this matrix is this, right? Remember, we saw this on exam 1. Let's see how this works out. Well, we're going to do A, B, C, D over here, and the identity matrix over here. So I'm going to break my own rule here. I'll do C times R1, and then maybe I'll do negative A. Actually, you know what? For appearance purposes, I'll do negative CR1, AR2. You'll see why in a sec. It's going to work out a little bit nicer. So we're going to wind up getting negative AC, negative BC over here, negative C, 0 here, and then A times R2, we're going to get AC, AD, and I guess this will be 0A, right? Because we're performing the operations across the matrix, right? Okay, so at this point, we'll do, I think it makes sense to do R1 plus R2. Right, so that's going to give us negative AC, negative BC, negative C, 0. Of course, that doesn't change. But what does change is that becomes a 0. We have AD minus BC, and maybe now we make a note of that. And then down here, what are we going to get? I guess this will become a negative C, and that'll be still an A. Okay, so now I think it's clear in theory what we need to do to make this reducer echelon form, right? Turn this into a 1, turn that into a 0, turn that into a 1, right? So we can do that. Which way should we do it? You know, it's not the most pleasant thing when you're working with general numbers like this, but we can do it. Let's make sure we have enough room, okay? Why don't we divide out by AD minus BC to R2. So you get negative AC, negative BC, negative C, 0. But here we get 0, 1. Well, that's a lot nicer. And then we get negative C divided by AD minus BC, A divided by AD minus BC. Okay. And now, I think we can see what we're going to do here, right? BC R2 plus R1. So we're going to get, I guess that's still negative AC, right? This is going to become a 0, 0, 1. So the left matrix is looking pretty good. The right matrix, ugh. Right? BC R2, so it's going to be negative C minus BC squared over AD minus BC. And then this will become ABC over AD minus BC. And then I guess this is still the same. Boy, this is looking pretty rough here. Are we sure we're going to get something good? Well, let's see. We're going to divide, we're going to do, I guess, negative 1 over AC, R1, should finish us off. And what are we getting over here? Well, we're going to cancel out a C from each of these terms. So that's going to leave us with, well, first off, so we're going to get 1 over A, negative 1 over, I guess the negative will cancel with the negatives here, so it'll be negative 1, 1 over A times 1 plus BC, what is it going to be? BC over AD minus BC. And when you do that out, that's going to simplify to, I'm just cross this out here. It's going to simplify to AD over AD minus BC. And then the A's will cancel. So you're going to be left with a D over AD minus BC. Let's see. This is going to be a little bit more straightforward. We're just going to get a negative, right, I guess it's a negative B over AD minus BC. This is a, and then this stays the same, right? Okay, so now when we factor out that 1 over AD minus BC, we get A inverse equals 1 over AD minus BC, and then it's, sure enough, D, negative B, negative C, A. There we go.